Hello, guys. How are you guys doing? Okay. Oh, sorry. Everyone can chat publicly. Cool. Awesome. Nice. Glad to hear you guys are doing well. Nice, Archer. Nice, Gabby. Okay. So today we have, just a reminder, we have our next exam on Thursday. Yeah, so hopefully you got a chance to review it, the practice. We can definitely go over Archer. So asked about number 2 and 4. Is that Archer? Is that from the practice? Okay, cool. Yeah. Let's go over the practice. And then, so before we do the practice, how about this? Before we do the practice, I do want to just do an example from chapter 8.4 of how to set up and solve a 3x3 equation, a system with 3 equations, 3 unknowns, and then also have you guys do one on your own, maybe like in a breakout room. And these are, they're a little bit tedious. And it's all about writing your steps where you kind of do elimination very carefully and keep track of everything. That's kind of the key. So let's do that, and then we'll go over questions 2 and 4 on the practice. But yeah, remember, just focus, just like the last exam. It's going to be really similar to the practice. So really learn how to do those types of questions. Okay, so yeah, let's do yeah, let's do example 1. I'm just gonna kind of go through that one because it looks the numbers come out nice. This is let me just see here. Oh, okay, yeah. There's a few things that we should talk about here. Okay, so let me share my screen. Okay, let's go to Notability. And okay. Today we're going to do 3 equations. Oh, I like blue. I'll stick with it. 3 equations three equations and 3 unknowns. 3 unknowns. And this is section 8.4, 8.5. And let's do one example. Yes, let's do example 2 on page 532. So this is example 2 on page 8.4, example 2 on page 532. Okay, so here's a system of equations, x plus y plus z equals 4, x minus 2y minus z equals 1, and 2x minus y minus 2z is equal to -1. So we have 3 equations and 3 variables. And we're going to do this basically like elimination and turn this into a 2-by-2 problem. So I'm going to label this carefully: equation A, equation B, and equation C. Okay. So does anyone see? So the strategy here is you want to pick 2 pairs of equations to eliminate the same variable so that you're left with 2 equations with only 2 unknowns, and then you solve that one using what we already know. So the strategy is kind of make it a smaller problem. So turn into a smaller problem. By picking 2 pairs, of equations and eliminating the same variable. Okay, can anyone tell me 2 pairs of equations that it's easy to eliminate the same variable? And it could be, there's no right answer here. Olivia, nice, suggested A and B. And which, okay, so A and B, nice, you could eliminate Z. Exactly, plus, if you see plus Z and minus Z, that's super easy. Nice. So equation A and equation B, the first and second, gets rid of Z. Now we need to also pick another pair of equations. So I'm just going to write it here. I'm going to write equation A, and I'm going to add them together plus equation B, and that's going to give me another equation. And you can write it out, and I'm kind of keeping track in my head was a little bit dangerous. So, I mean, if you, it just becomes really messy if you write everything out. So A and B and eliminate Z. So let's eliminate Z. And what's another pair? And remember, you guys, you're welcome to also chat to everyone. Olivia suggested A and C because of Y. That would work as well. But let's stick with, if we stick with eliminating Z, let's pick another pair to eliminate Z. You could do A and C as well. That's also good. But then you need to focus on another way to eliminate, another pair to eliminate Y. So what's a good way to eliminate Z from another? B and C. And in particular, what do we need to multiply B by in order for it to cancel with the other Z? Nice. Yeah, we multiply it by, let's say, -2. Or maybe I'll multiply the bottom by -2. Just be careful which one you multiply by -2. But you want a negative because this is, these have the same sign, so you're going to really end up subtracting them. But this one needs to have a 2 in front. So let's do it. Let's do, I'll do a negative 2b. And you can kind of treat an entire equation like a variable in a sense, because you're just like, you're grouping them. Okay, nice. Okay, so now let's look at what we get. When we add together a and b, do you guys want to just message me what equations you get? And you have to carry a little bit in your head, so there's a risk of doing a mistake here. So try to be as careful as possible. And when I do doing this approach, sometimes it's easy to make a mistake. So what is our first equation that will only have x and y? Yes, exactly. Gabby, perfect. You want to get rid of the z for both equations. That's our strategy. And the reason we do that is once we've done that, we'll have a 2x2 system which we can solve. And if you're kind of comfortable with the idea, just go ahead. You don't have to. You can keep working and then see if you can follow through with the whole strategy. Archer, yes, you could have done 2b, but then you would have wanted to do minus c. Oh, shoot, Archer, that's a good point. Maybe 2a plus c is better because you don't need to do any minus stuff. Do you guys want to do 2a instead? That's actually a good observation. Whatever you do, just try to always make your life easier when you're doing these problems so that you don't need to, if I can avoid subtracting stuff, I always do that because I know subtracting is a big risk because I might miss a minus sign. So that's a good observation. You look for these things. That's a nice one. So 2a, let's do this. 2a plus c is way better. Both will get you to the right answer. So as long as you're following the algorithm, there's no, the strategy, there's no wrong way to do it, but some ways are just less prone to error. Okay, so a plus b, you'll get 2x minus y is equal to 5. I like that. And then how about 2a plus c? Anyone want to chat or say what they got for 2a plus c? Nice, 4x plus y, because we're going to do 2x, so that becomes 4x plus y. And you better not get any z's because you tried to cancel. That was the whole point. And then multiply it by 2, subtract 1, you get this. Okay, sweet. So now we have a new system of 2 equations and 2 unknowns. And what's nice about this system? What's the easy way to solve this one? Oops, I'll stick with the blue. What's the easiest letter to eliminate here? Nice, nice. Yes, let's just get rid of the y. Just combine them. So we'll get 6x equals to 12. That implies the following, that x is equal to 2. Now you can plug in what is, just kind of without even writing anything down, you can just look at it. Just be careful though when you do it this way. Just by looking at it, what should y equal? Plugging into either of the 5 or the 7 equation. Yeah, y equals multiplied by 2. Oh, hang on. I think it should be y equals to -1. Because if you plug in the 2, you get -1. So plug in, and for the rest, you want to plug in And then the last one, let's plug in into the easiest equation that you can. Plug in 2 and y is -1 to get z. And what do you guys get? Oh, yeah. Okay, let me just clarify here, just because just to make it clear. You plug in the 2. Now that we know that this is 2, we can plug it into either of these equations, either here, or we can plug it in here. And then once you do that, let's plug it into the first one. We get 2 times 2 minus y is equal to 5. Solve for y, you get 2. We get 4 minus 5 is equal to y. Subtract the 5 and add the y. You get -1 is equal to y. Oh, Kristen, is that okay? Kind of just it's called back solving. Cool. And then we do the same thing to get z. Nice, Archer. We do the same thing to get z equals 3. We plug in 2 and -1. You can pick any equation you want, and then you'll get z equals 3. I would pick the first equation. Okay. All right, so I got some good ideas here. There's other ways of solving this, and maybe I didn't do it the easiest way. Like maybe there's some ways to save some steps. I saw a few students suggested -2b. Oh, nice. Oh, sweet. That's pretty awesome. So Ariane suggested to do, and another student as well, suggested to do -2b plus c, kind of, I think, how we were first approaching it. And when you do that, the x's actually will cancel, and you'll get y is equal to -1, or you'll be able to solve for y right away, which is nice. That's really good. And then once you have y, you can plug in and get the x. So yeah, because it is actually pretty sweet, because these guys are in the same ratio. These are double each other, and these are also double each other. So if you try to cancel out the z, you'll also end up canceling out the x. So it just makes your life a little bit easier, but nice. And so our final answer is this. And really, there's not much of an excuse to like not know if you got the right answer. What should you do once you have, like, try to quickly do once you have these numbers? Especially if you have the time. Yeah, just plug it into everything, and just make sure it checks out. That's an easy way to check if you got the right answer. And I really recommend doing it for these questions. You're not going to lose points if you don't do it, but it's an easy way to catch mistakes. And personally, when I've solved these, the first go around, I usually do something wrong. So, and I'm not going to be too strict on like if you made one minus sign error somewhere. Unfortunately, it's going to throw off all of your work. So I'll try to kind of read through your work, as long as you kind of follow the strategy and I see you know what you're doing. You'll get almost full credit, maybe like half or even less off. But I'm really looking to make sure you understand the steps of how it works. And I ask, what we're doing there is we're picking a pair of equations. So our goal is, in the beginning, we have three equations, 3 unknowns. It's a little bit tricky to solve. We don't know how to do that. So what we do is we use 2 equations to get it down to an equation with only 2 unknowns. And we use another 2 equations, this time a and c, and we eliminate the same variable that we just did, and we have a separate equation with 2 unknowns. And that is now a problem that we can solve. So we've turned a complicated problem that we didn't know how to solve into a problem that we could, like a smaller problem that we do know how to solve. Doesn't give us the complete solution, because we still need to go back and get z, but at least now we can find x and y. Did that help a little bit? No. Let me think. Well, how about this? Let's try another example, and then let me see. Oh, well, what so let me think of it another way. We set them equal. Let me see here if there's some nice numbers here. Because I don't want to do anything with bad numbers. So let me see. Let's try number 11 from the book. And Ane, what idea kind of do you think you felt the like a little bit confused on, or like what idea with the a plus b and 2a plus c like?
Okay, so the thing that confused me like the most was
Sorry, I can't hear you.
the. Can you hear me now, or no? Is it still bad? Wait. Can you hear me better now? Or no. Can you hear me?
Let me think here. We'll see this later in another kind of interpretation. But yeah, I think the best way of thinking of it is like you're using the information that's given to, if two equations with three variables are have to be satisfied, then when you combine them, they still have to be true. So what you're doing is you're able to kind of reduce the problem into a smaller problem. That's just kind of the goal. Let's try one together. Let's try number 9 from the book, 537. So this is 8.4 example. This is exercise 8.4.9. Let's see. And so we have x minus y minus z equals 0. And then 2x minus 3y plus 2z is equal to 7. And then negative x plus 2y plus z equals 1. Okay. I'll give you guys a little bit of time to try to solve this. I'll be right back in a second. But if you have any questions, message me, and I can even make a little breakout room and work with you individually for a second. Okay, but try to do this on your own. If you want to chat with each other, that's also a good idea. Yeah, let me know how you guys do. And we might, some of you might do it different ways, but you should all hopefully you should all get the right answer or the same answer at the end. This is A, this is B, and this is C. Let me know as you're working which two pairs of equations and which variable you chose to eliminate. Yeah, this one actually, I realize now, you might be able to do even a little bit of a shortcut here. Hmm. Okay, so a few students mentioned that, and these questions are from the book, so you might get a fraction. Just be careful with that. Okay. All right. So let's go through it together. I saw a few of you made a really nice observation. They don't always work this way, so but we can take this little shortcut. So if you pick equations A and C, what you notice is you can do A plus C, and that would get you to 0x plus y plus 0z, all right, 0x, is equal to 1. So we know y equals 1. And let's pick another pair. And let's say I wanted to, I needed to pick something like in the beginning, pick what letter you want to eliminate. So let's say eliminate z. Maybe I would pick, after that, I would pick 2a plus b. That would also eliminate z. So 2a plus b. If you look, the reason I picked 2a is because this is minus z and this is plus 2z. So I want to pick twice the first row plus the middle row. That would get rid of z. And so when I do that, I get 4x plus b. And please keep track of my work here because it's very possible. So 2x, that would be negative 2y and plus negative 3y would be negative 5y. And by design, I have 0z, so that's good. And I also still have just 7 because I'm adding 0 times 2 plus 7. Okay, so maybe I shouldn't have written all these like extra 0z's because it makes it look a little bit more confusing. But this is our system now. Did anyone do this? Anyone have any questions on the steps here? There are lots of different ways of doing it, so this is not the only way you could have done it. But please give me a yes if everything, even if you didn't do it this way, if you follow the steps and it checks out. Cool. And also, are there any questions? All right. So now it's pretty nice because you don't need to do elimination again. We saved a step because we know y is equal to 1. Then we can plug into the second equation. We don't want to plug into the first one because unfortunately this is a special case where it's got a 0x. You don't have to keep the 0x. Yeah, you don't have to write it. But I'm just writing it to show most of the time when you do these, that's kind of a special thing that would happen to get 0x. Most of the time you'll have to do elimination one more time. But now we have y equals 1. We don't want to plug into the first one because that wouldn't give us information, but we can plug into the second one and we get what? X is equal to 3. If you plug in plus 5 and divide by 4, we get x is equal to 3. And yeah, it's easy for me to make a mistake here, so please let me know if you spot anything off. Now the last step is plug into any of the equations. So this part is called back solving. So when I first plug in, let me kind of highlight it. First I plug in y equals 1 into there to get x equals 3. Then I plug in x equals 3 and y equals 1 into both this one and that one. And what would that give me? 3 minus 1. Oh, that's nice. That tells me that z is equal to 2. Okay, let's see. One student asks here, how do I get the 4x minus 5y equals to 7? So I did twice the first equation, sorry, 2a minus, 2a plus b. So let's kind of do that carefully on the side here. And I just did that in my head, and I encourage you to do that a little bit as well, just those steps. Oh, okay. Oh, yeah, you can do B and C as well. Let's see. And yeah, if you use B and C, so let me try B and C. So one student tried B and C, just to double check. If you use B and C, you want to do B minus 2C. The reason you want to do that is because here you have 2Z, and here you have just a regular Z. So you want a minus 2 there. So that would be what? Minus 2C would be 4x minus 3 plus negative 4 is minus 7y. The z's will cancel, and then you're left with 5. Six x minus 7. So, Gabby, did you catch your mistake with the 4x? I think that's
because
where
like
maybe
I thought when
might
you
have,
because
gone wrong.
I thought you had to add
Because you
the
do 2x
B
plus
and C
2x.
together
So
for the
this would be
equation.
another way you could have done it. Does that look okay?
Yeah, I don't know where I messed
And
up
these
on.
problems are tough because, nice. You know, you might, just like that, you know, you make a mistake, like instead of 4x, you write 6x by accident, and it will throw everything off. So that's why at the end, oh, wait, yeah, guys, I can't hear anybody. Was anyone talking? Oh, my bad. Yeah. The class is pretty quiet, but today it's like extra quiet. Let me see. Sorry, guys. Oh, can someone say something?
Can you hear
Testing?
me? Hello?
No, I don't hear you, Gabby. Oh, let me see. What's going on with my audio? That kind of sucks. Hang on. Testing, testing. On 3, say your favorite animal. 1, 2, 3.
Turtles. Oh, giraffe.
I can't hear you guys. Can you hear each other though?
Yeah, we can hear.
Seal.
Oh, you guys can hear each other, but I can't hear you. I can hear. Okay, my hearing is good. What is going on? That's a weird Zoom bug. Well, yeah, let's keep going. And then yeah, maybe if next time I'll show up a little bit early, and I'll try to sort it out, because I don't want to kind of cancel and rejoin. But yeah, that's bizarre. Could be my computer is just like it's an older computer. It's from 2011, so. Oh, okay. Gabby, yes. Hang on. One student, Gabby suggested that she mentioned that she did everything right, but the answer came out differently. Yeah, these can be frustrating because like there could be a tiny error somewhere. So Gabby, can you walk us through, and as you walk, maybe tell the class, maybe just say, type in the chat so I can see it as well, or if you want, hang on. Sorry, just going to reconnect here. If you want, you can also annotate. So yeah, which pair of equations did you use?
I used B and C. for it.
So you did
I don't
B
know if
and
you could
C.
hear me.
Did you get the 4x minus 7y equals 5 thing?
No.
Oh, okay. That's the when you do b minus 2c, just make sure that you get this thing, because you'll get 2x minus negative 2x is like plus another 2x. So that comes out to 4x. So everything else looks right, but it just that one coefficient, if it's wrong, would mess everything up. Because if you want to eliminate the z, we got to multiply by this by negative 2, because we want a negative 2 here. So when I multiply this by the whole thing by negative 2, this becomes a plus 2. Why is it minus b and c? Nice. Hannah, why is it minus b and c? Can you clarify that one, please? A and B. Oh, yeah. A and B are adding together. Perfect. Yeah. So that's just how I like to do elimination. Sometimes with elimination, I add them together when the things I eliminate are opposite sign. So I just add two things together and they kill each other off because one is plus and one is minus. Sometimes I subtract things like B and C. I would subtract them because this is just 2z and this is z. So I would do this one minus 2 of these. That's how I think of it. Or if you want, you could alternatively write this as b plus negative 2c. That's also good. So I try to be pretty flexible just with when I do elimination. I don't have to. You don't have to do it in just one way. You don't have to say, oh, always make them opposite and then add, or always make sure they make them the same and then subtract. Just kind of whatever you see that's convenient. I just like to do it so I avoid writing too much. Like if I write too much stuff, my paper gets too cluttered and it's a little bit hard for me to keep track of what I'm doing. And again, just like a few students, as you experienced, made mistakes, and make sure you're practicing these because it's really easy to make mistakes, and I make mistakes on these. Once you get your answer, plug back in to make sure you're not doing it wrong. Unfortunately, even on tests, sometimes I'll be really careful, but in the past, I've made a system and then realized, wait a second, there's some issues with this system. It's just kind of a tricky type of problem because you can't just look at it sometimes and see the answer. You have to do a little bit of computation. Okay, so let's move forward and talk about some interesting things about 3x3 systems that you don't see in 2x2 systems. And this next week, we're going to start a new section, which will be like a short section from, it'll be like an extension of 8.6 to 8.7 or something about matrices. So we saw, before we do that, I want to talk a little bit about the geometry of a 3x3 system. So if you guys remember, in a 2x2 system, can anyone in the chat tell me, and you can chat to everyone, in the 2x2 system, what is the picture? What is the underlying geometry? So what should you have in your mind a picture of whenever you solve a 2x2 system, if you want to think of a picture? Nice. So we have or I would say maybe the plane. We have like a flat plane. And what do we have on what objects are we really talking about when we have a 2x2 system? What are the geometric objects that we usually can interpret each equation in a 2x2 system? Anybody? What did we talk about for a little while for 2x2 systems. What are those things? Each equation represents a not matrices, not the matrix thing. Yeah, a little, yes, the lines. Yeah, in a 2x2 system, the underlying geometry is each thing represents a line, and we want to see where two lines cross. So this is line A, this is equation 1, this is equation 2, and the little red dot is the solution. Right? Please hit yes if this kind of rings a bell and you feel comfortable. Like this is the thing we were talking about, like interpreting with parallel lines that have no solutions. Awesome. Let's see a few more yeses on the board. Let's see if we can get to 10, at least 10 yeses. Wait, there's a no? Kind of. Oh, okay. Yeah. So just to remind you, if we have an equation like this, x plus y equals 5, and 3x plus 2y equals 7, you can rearrange each of them into y equals mx plus b form and see that they're talking about two lines. And where those two lines cross, that's your solution. And remember we talked about like, oh, wait, two lines. If we have two equations that are really the same equation, but have different, like the numbers out here are not in the correct proportion, then it's like two lines that are parallel but never cross. So that would be a case where there's no solution. So we saw with two lines that there's three possibilities. There's either one solution, or possibly no solutions. This is when you get things like when after elimination, you get things like 0 equals 3 or something. You get something crazy where it doesn't make any sense after elimination. Or you can have infinitely many solutions, like if you have two lines that are the same thing. I made them green and purple. Those colors look nice. So two lines, you could have infinitely many solutions. And what would happen there is you get something that says 0 equals 0. And that means that that really the equations were the same, and you have no more information to find that one intersection point than you had before, because there's an infinite number of points that where two lines that are right on top of each other meet. So this was the case for 2x2. Please hit yes if you feel pretty comfortable with this idea, and hit no if you still kind of a little bit shaky on it. And we'll do, tomorrow maybe we'll do some practice on this idea of the 2x2 system, kind of when they have infinitely many solutions, when do they have no solutions, stuff like that. Any questions at all on these three examples? Because we're about to take it to the next dimension. Okay. So does anyone want to take a guess? And you might not have seen this before, but does anyone want to take a guess about what kind of picture, if you were to graph this, what the heck is this thing? Or, whoops, or this one? What do these things represent? Anyone want to just take a wild guess? And message me in chat because I can't hear you. Nice, it's in 3 dimensions. And what is it? It's definitely 3-dimensional. It's not a parabola, but that's a good try. What? Oh, triangle's not bad. You can interpret it as a triangle. So it has a nice. Okay. Yeah, straight line across like a L with a line in the middle. So let me show you. There's an app on Mac called Grapher. And let me just pull it up here. And let me stop my share. Let me pull this up. Okay, let me first let me just pull this up. Sorry guys, let me share screen. How do I do that? Share screen. Desktop, share, Grapher. Oops, Grapher. Okay, 3D graph. And there's ways to do this online. I'm going to do gradient. Yeah, it shades it. Okay, now let's check this out. So that first equation was x minus y minus z equals 0. And you see this one says z equals. So it wants you to write it as, I don't think it can do, let me see if it can do, if it can do this, x minus y minus z equals 0. Oh yeah, okay, it can do that. Cool. So check out this shape. What is this? Does anyone know the name of this thing? Okay, it is a hexagon. It is a hexagon, but it's supposed to represent a piece of paper. It's a coffin, yeah, anything like that for Halloween. It's supposed to represent a piece of paper that goes on forever in all directions. So just like when you draw a line on a piece of paper, you can't draw it forever, right? You have to stop eventually. So it looks like a line segment, but there's really, this is like an infinite piece of paper that's stretched out forever. And if you have a Mac, it's really fun to mess around with Grapher. There's other websites. I'll try to look. There's other websites online. I don't think Desmos has it, but there's other websites where you can do fun like 3D graphing stuff. So the third dimension is z. So check this out. If I do z equals x squared, for example, I get like a parabola. But the idea is, and this is something you guys can think about. Can anyone? Oh, that's not what I wanted. Can anyone explain why z equals x squared has this version graph? What does it look like? You guys see it's kind of like the parabola, but it keeps repeating because for every y value, this is the y-axis, this one is the x-axis, and the one going up is the z-axis. So like if you plot the graph z versus x, you're going to get a parabola that looks like this, right? And as you move around the y, you just get copies of the same parabola lining up. But let's take a look at this. Anyone want to guess what this would look like if I do plus z equals, if I do this shape, oh, this one's a little trippy. This is called a paraboloid, where it's kind of like, it's like a parabola, but it's like a 3D parabola. In fact, it's actually a lot like a satellite dish. If you zoom in a little bit, you can kind of see, whoops. So we're zooming in. Do you guys see that this is kind of like a satellite dish a little bit? It has the surface is the same, has like every cross section is a little parabola. So these are surfaces, and they're surfaces. One way to interpret them, have you guys ever seen a topographic map of like, you know, some mountain ranges? Has anyone ever seen that? Or you can do it on Google Maps too. So what we're kind of thinking about when we write a formula like z equals something, we're saying write the height as a function of your xy position. So walk to a place on the xy plane and then go up a certain amount. And when you do that, you're going to get a surface. And you can similarly like draw a topographic map of this surface on the xy plane, and you can get, here you'd get a bunch of circles. But anyhow, let's go back to our problem. Our problem here says, yeah, it's these types of equations. So if I rewrite it, everything, the first one, for example, I can rewrite it as z equals x minus y, like that. And you see that it's because the numbers, the z is a function of just a regular x and a regular y. There's nothing being squared. There's only maybe a number in front of them. This is a lot like each cross section is just going to be a line, but it's kind of changing in different directions, and it comes up to be a plane. And later in math, you can learn a really nice way to describe how to think of this plane and how to orient it. But the idea is it's just a flat piece of paper that goes on forever. So, okay, I'm going to rewrite this one as it is in our example. X minus y minus z equals 0. Okay, and I'm going to add a new equation. How do I do that? Let me see. Sorry, guys. Wait. I want to add a new equation. Okay, now can anyone, before I put this new equation in, can anyone tell me if you have two infinite pieces of paper floating around in 3D space, what kind of object do they make when they intersect? You have two straight flat pieces of paper, and they're called planes. So two planes in 3D space. When they meet up, what sort of object do they make? What do you guys think? Just imagine two pieces of paper going on forever, and then where do they cross? They're going to cross each other. What do you think they're going to make when they cross? Yeah, like when they meet each other. So let me kind of show you with my. So this is a flat piece of paper, right? And imagine it continues on being flat in every single direction. And then here is my iPad, right? And they're going to cross, right? This will eventually cross over here. What kind of shape do they make? Can anyone visualize that? Just take away everything except where they cross. What are you left with? And it takes a little bit of imagination to see it, but once you see it, it's pretty. It's not going to be a T. Where do they both meet? Not quite a T. This shape is a T, but it take away, like, it's actually not meeting here. It's only going to meet along on a ridge, which will be a straight line. Exactly. Ouch, that hurt my wrist. Let me plug in that straight line. Let me plug in the next equation so we can kind of see it. So 2x minus 3y plus 2z equals 7. So this is another plane. Let's see how it looks. Okay, it's not showing up here. Let me zoom out. Oh, there it is. Whoops. Now that the other one's on. So cool. Do you guys see this? Do you see the two pieces of paper? Do you see where they meet? Where they meet, it's a little bit hard to visualize it, but they meet at this line. I think that's pretty cool. This kind of looks like to me like something. Have you ever guys had that football with the, what's the name of this thing? Like a Nerf football, but at the end there's the fins, I guess, at the tail. Have you guys ever seen that football? Yeah, the Nerf football torpedo thing. Exactly. I remember that, like, brings back a memory from like elementary school. if you haven't messed around with that, you definitely need to throw it. It also makes like a fun sound as well when you throw it, and you feel like you can throw it really far. Okay. Anyhow, yeah, this is pretty cool. It's like a pair of fins, and they meet up on the line, along the line. Okay. Now, so just imagine, so two of the equations meet. They give you one line, and this is a weird line. It's not a line on an XY plane. It's just a line, like a piece of string going through 3D space. It can go in any direction. It's not curved. It's a straight line, like a straight piece of string, but it goes in some random direction. Now, if you have a third plane that you want to see where it crosses, where all three of them meet, where does a piece of string that goes on forever meet a piece of paper that also goes on forever? How do those two things cross? How does a straight line, or like an arrow or a piece of a string that goes straight, cross with a piece of paper? When they cross, what shape do they make? What shape is like left over in the crossing? Not a parabola, even simpler. It's actually a very simple shape. Maybe not even a shape. Let me write it down. Archer, yes, it's going to be an intercept, or just, if you have a piece of paper, right? Here's my Apple Pencil. This is the third equation. And the first two equations, in order to satisfy them both, you're actually just going to get a straight line. So that's your straight line. And then you want to see where it's going to meet the plane. It's going to pierce, and I can't do the magic trick, but if I could, it would go through my hand and keep going. And you see that it pierces at one point. And that's going to be your solution point, where all the three planes can meet. So I'll just put in the last equation here. And let me see. This is going to be, let me write it how they have it here. Negative x plus 2y plus z equals to 1. Okay, now we got a bunch of things. This becomes a little bit harder to visualize, unfortunately. But do you guys see that they all kind of meet at this one point? There's this intersection point here, right here. And that's your solution point. It's not quite the origin. Let's zoom in. It's not exactly the origin. The origin is kind of covered up here. The origin is like right there. But these guys, and if you look at the solution that we got, what was it? 1, 3, 2. It's not that far from the origin, but it's like, yeah. This is a pretty cool abstract shape. But yeah, this one point is where they all meet. Please hit yes if this visualization is a little bit confusing, but you feel like it kind of makes sense. And it helps you kind of understand the picture, the objects that we're actually working with. And hit no if it's like you have no idea what I'm showing at all. Okay. Those of you who had no idea, is there any question, any part of it that maybe I could clarify? Because I'm happy to, I really like talking about this stuff and showing these pictures. So any part of it that would help to go over again? Okay. So that's how, these objects, they're not lines, they're planes. So we have three planes where three planes meet, that's at the same time. If they meet at a point, that's our solution point. Now, let's think about, just like with lines, something interesting could happen. And this is a kind of open-ended question. There's just a few interesting things that can happen. Can anyone suggest what is something funny that can happen where three planes that don't meet at exactly one point? There's a few more interesting situations than there are with two lines. So I'll leave you guys to think about this for a few minutes. But if you have an idea, please message. You can message to everyone in chat. So think about it. What are some kind of configurations you can make with 3 pieces of paper that go on forever, where they don't just meet at one point? Anyone have any ideas? There's a few interesting ones, and I'm sure there's no like right or wrong answer here. Can you think of can you think of ways that 3 pieces of paper, you can like put them in space somehow, they go on forever, but they don't meet at one single point? Maybe they don't even meet at all. Oh, nice, Archer. So that's a great one. If you make them all the same, they will meet everywhere. So that's a good example. If you have 3 equations that are all the same, maybe like, one of them is twice the other or whatever, when you do elimination, you're going to get 0 equals 0. So there's not going to be, it's indeterminable or underdetermined. So you won't be able to figure out the point. So that's a really good example. Can you give me an example where there's no solutions at all? So if all of them are the same, then all the pieces of paper are right on top of each other, infinitely many solutions. How about if there's, how could we make it so that there's no solutions? Any ideas? I'm going to type something in here. What do you guys think about this example? Let me just do not 20. How about? What's going on with these 3 equations? Anyone want to explain? Will these 3 ever meet? Yeah, they're not touching. They're all parallel because it's kind of like in 2D, the coefficients in front of the x, y, z, they kind of determine the direction, or they do exactly determine the direction of the plane. Just like the numbers in front of the x and y determine the slope, it's the same thing in 3D. And then if you offset them by different values with a constant number, that's kind of like the z-intercept, and so they're all going to be parallel. So that's similar to a line. But is there anything else in 3D that we can do so that they don't no three planes ever cross at the same time? Is there any configuration another configuration we can make? So so if you take a look in your book on page 537, let me see here. They have some, there's another way that you can take, do you guys see that you can take 3 pieces of paper? Actually, I can show you with my iPad here. Imagine each part of this iPad is like a, you can make a triangular prism with 3 planes, And this will have no solutions, because do you guys agree that there's no point where all three of them meet? Only the lines, two of them can meet at a time, but there's no place where three planes meet at the same time. So that's another way that you might have an inconsistent solution, inconsistent system. So it's a little bit more interesting than just two dimensions where you can only have parallel lines. Yes, maybe we can mix this up if we did. Yeah, so this is kind of fun to mess around with. If we did something like that. Yeah, so this would be a nice example where, let me just see here. Oops, let me make this a little bit different. Yeah, I think this is the case where if you zoom out, the triangle is not the best there, but you'll see you're going to get a weird triangle here, and they're never actually going to meet. And if you try to solve the system, you'll see that it's inconsistent. Nice, Archer, good example. And then lastly, there is a case where it's also not enough information, but it's not all three of the planes smashed together. You could do something like the NERF thing, where they're all the planes are going through the same line. So you have the NERF thing, and then you have another plane that crosses right through that line. So that's an example where it's going to be underdetermined as well. So the moral of the story is that in 3D, the configurations that can happen are a bit more interesting, but essentially you look for the same thing. When you're doing elimination and you get something that doesn't make sense, that means it's inconsistent. Otherwise, it's going to be, if you get 0 equals 0 and all the variables canceled out for somehow, then you're going to get possibly infinitely many solutions. All right. So let me quickly, are there any questions on these ideas? And in the book, they go through them pretty well. Do you guys want to see a cute picture? Let me see here. Good. Introduce you to the baby girl. Let's see, there she is. She's Samantha. She's very small, yeah. She's quite a handful right now. Thank you, guys. Okay, I'm going to go back and let's just quickly set up questions. Yeah, she's got a strong fist. Okay, let me share my iPad. iPhone, iPad, AirPlay. Yes, very, very squishy cheeks. She's got a little bit of a heat rash now, which was kind of hot. But let's see. Oh, I want to go through. Just open the. Okay, Math 96, classwork. And then tomorrow we can definitely spend more time going over the details of the test. Please please try to do your best on the practice test before tomorrow so that we can, that you're all set up for it. Oh, okay. Number 2, and Archer, which one did you ask also about? 2 and 4? 2 and 4, okay. So, so 2 is really relevant to what we just talked about. 8x plus ay, this is number 2. 8x plus 8y equals 16, and 10 10x plus 35y equals to b. And the question is said, what values of a and b a and b have no solution. So underline if it says infinitely many or no solution, because the answer is going to be a little bit different depending on what it says there. Okay, quickly, if it has no solutions, what shape are we looking for? Are they going to be intersecting one time, parallel, or exactly the same line? Nice. Gabby said that they should be parallel. Perfect. So we want them to be parallel. If they're going to be parallel, that tells us that the slopes got to be the same. And the slopes are determined by these numbers. So if these numbers are in the same proportion, then they're the same. So you can either do proportions like this. 8 to 10 is 8 to 35. That's totally fine. So let's try to make them the slopes the same. You can also do proportions 8 to a is 10 to 35. So either way you want to set it up is fine, because with proportions you can cross multiply and it's the same thing. So let's take a look here. 8. I like to just do it comparing equation to equation. In order for it to be parallel, 8 to a has to be a to 35. And now we can try our best to solve this. 4/5 is 8 to 10. And I know 35 is divisible by 5. It's 7. So if I do 35 on both sides times 8/10, I'll get equal to a. And maybe you could also, instead, maybe you would do cancel what you can. So this is cancel the 5 here. So leaving you with the 2. This will be 35 over 10 is going to become 7 over 2. And the 2 cancels, leaving you with a 4. So this is a is equal to 28. So that makes them, or 8 times 3.5. That's also good. Yeah, that's great too. A is going to be 28. That makes it parallel. Now let's think about the intercept. What we want here is we don't want the intercept to be in the same proportion. We just want it to make sure that it's offset. Because if it's in the same proportion, that means there's infinitely many. So let's again do 8 over 10 equals 16 over b. And you have to be careful here. Just make sure you do the algebra correctly. So do b equals cross multiply 8b equals 16 times 10. Divide. Before you multiply, I always like to make sure I divide and simplify. So when I divide by 8, I get b equals to 20. Or you could just look at the proportion. 8/10, oh, that's going to be 16/20. So b is exactly right, Archer. B, you don't want it to equal to 20 because you want it to be offset. So it's not the same line. Okay. So please try this one again. If you haven't done it yet, don't just kind of say, oh, I just saw the solution, I don't need to work on it again. Think about it again, maybe tomorrow, tonight or tomorrow during the afternoon. Yeah, let's do 4. Let's do 4 tomorrow. The hint I'll give you is that it's very similar to the, it's very similar to the T problem, where like the person is mixing the 2 T's. And the 2 equations to think about are, the first one is a total amount that you're making, and the second one is the total cost, or the total like amount of the actual amount of juice, which is similar to the total cost. Oh, 28. When you multiply 35 35 times 8 over 10, because I multiply both sides by 35 here. Archer did it a nice way. You can also, you can cancel the 10, you do 3.5 times 8. So you can do 3.5 times 8. And 3.5 times 8 is going to be 28, because it's 3 times 8 plus half of an 8, which is going to be 24 plus 4. So that's another way you can do it. The way I did it is I just canceled a bunch of stuff that I could. All right, guys. Well done today. I hope you enjoyed. If you know, mess around with Grapher. I remember when I was in high school, I just found Grapher on my computer. I just plugged in random stuff, and you get really cool shapes. There's no wrong or right answer. You just have fun plugging in whatever crazy things you want and see what shapes you get, and then try to think about, wait, why does it look that way? That really helped me a lot later in later math courses. All right, guys. Well done. I'll see you tomorrow. You too.